Thank you, everyone, for that wonderful applause. I know it's not breakfast, but that is sort of the theme this morning. My name is Casey Best, Director of Threat Intelligence at Silent Push. We're a cybersecurity startup that specializes in threat intelligence, protection for brand impersonation, phishing, attack surface management. We have a number of other offerings, and what I'm going to show you is how we handle and provide preemptive threat intelligence by finding attacker infrastructure before it's weaponized and the methods that we use to do that. So let's dive right on in. What is a hash? So the literal definition is the end result of a function that converts or maps an arbitrary size set of data into a fixed size set of values, and I can already see some of you falling asleep. What that actually means is that it's a way to turn a big amount of data into a unique set of data that we can then use. And how do we use that? Well, you can use it for checksums, randomization, a number of different ways. But what we're going to do today is use it to quickly verify that a given set of data matches another set of data. So if the hashes of two sets of data are the same, then barring collisions, which are mathematically extremely unlikely and can be investigated, then they can be assumed to be identical. And then that means we can match them, right? I'm going to keep saying match because it's super fun. This is the last slide that I have with somebody super excited to see a hash brown, but I just love that slide. All right, so what about fuzzy hashes, right? So the hash gives you an exact match, which is great, but what if they change something? What if they change a line of code? What if they change a letter on the page? What if they change a little bit about their network infrastructure? Not useful when you're looking for those exact matches. So what we do is we use fuzzy hashes. They can be used for essentially similarity searches. If their changing infrastructure is similar to the rest of their infrastructure, we can still catch them. And essentially, thanks to the power of math, we can use those algorithms to find everything else that's similar to that infrastructure. And if you want a really in-depth explanation of how that works, I invite you to Google it, because my answer is math. Now, what was that you said about adversary automation? Threat actors are evolving all the time, and they are embracing the scaling efficiency that automation brings. And I hate to be the one to say artificial intelligence for the 755th time today, but they are embracing it, and they're embracing it by using AI-generated content for obfuscation, just like the slide with the hash brown guy. I didn't draw that. My skills are not that good. They're using that to create phishing pages that look even more realistic, or they're using it to create fake company websites, or they're using it as part of their automated website builder that we've seen. The rise of those websites are enabling them to scale up to thousands of domains and hundreds of targets instead of just a handful or whatever. We're also seeing them deploy infrastructure with the aid of domain generation algorithms, DGAs. So now they can just automate all of it up, and I'm sure some of you have seen that, where they scale the level of their infrastructure up to a ridiculous amount to track, and we can actually use that as a way to fingerprint their infrastructure and find everything that they're spinning up as they're spinning it up. Now, those three things are what are contributing to IOCs losing their effectiveness for defense. Attackers still expect to get caught, right? They're going to get caught. If 4 or 5 pieces of their infrastructure get put out in a report, then those are now disposable. They can throw them out. But if they've already planned for that, then the other 400 or 500 pieces of their infrastructure are still able to be used for attacks. And that's what we're going to explore how to capture today. So I have to give a little bit of a disclaimer here, because who's watching the watchers? As much as everybody here is watching me talk, the threat actors are also watching me talk, and they're trying to find how we find their infrastructure. So I've had to obscure a few details in the slides, specifically the type of hashes. That information is available in our platform, and I invite you to go to our community edition and sign up, and I can show you a little bit more, or after the presentation I can show you more. But for now, I can't share the specifics of how we generate some of these hashes, because if I did, then in 10 minutes after this gets broadcast on YouTube, they were going to start changing their infrastructure, and we don't want that. So, first hash I have for you today is a hash that we're using to track scattered spider, a name that I'm sure several of you are already familiar with, so I won't bore you too much with the definition. They're responsible for numerous breaches over the past couple of years. There's a list of the different TTPs that we've observed. They're part of the community, or the COM, an extensive online community that excels at social engineering attacks. They've got ties with Russian ransomware gangs. All in all, bad actors. They're known for using a large amount of phishing kits. We're tracking many of them. And this one right here can be tracked with this particular hash. So we took this domain, mytwilio.com, right? And aside from the domain not matching Twilio's infrastructure, there were a few suspicious aspects to the page that made it immediately apparent that it was a phishing kit. And sometimes when an attacker is creating phishing kit, or was creating copies of websites out of these phishing kits, the more perfect a copy they make of a website, the better able it is to fool those victims that are going to it, the easier it is for us to catch, which is what we did here. So pivoting on a single hash, an MD5 hash, so the exact copy matching that I mentioned earlier, this actually returns hundreds of other host names, all from the same phishing kit. So we can use this as a target-independent fingerprint that can then be expanded into generating the creation of new fingerprints, and so on, the same threat hunting cycle that we're all used to. But this shows sort of the power here. The live examples, those were live as of the last time I ran this query. But you can see that it doesn't matter who they're targeting, right? We can still find everything that they're using in this phishing kit, everything that they're spinning up with this phishing kit with a simple hash. And that gives you the preemptive intelligence that you can use. Here's a couple other examples of those phishing pages. You can see Amica, Gemini, and I'm sorry, the text is a little bit too small for me to read, but a couple more examples of their infrastructure. So again, it's close, but it's not perfect. Or at least it's not perfectly hidden. Number 2 here is Prolific Puma. So they provide URL shortening services to cyber criminals that lets them hide their infrastructure. Because if you get an email that's, hey, click on this link to badguy.com/give me all your money, I'd really like your bank details, please, you're probably not going to click on that. Hopefully you delete the email, even better if you send it to your IT team, or at the very least, nobody else in your organization is clicking on it. But through this service, they have served almost every type of malicious campaign over the last 4 years. Phishing, spam, malware, etc. So in order to disrupt this, in order to find the infrastructure that they're using, we have to get to the root of how they're doing it. So similar to other popular and legitimate URL shortening services, they have a specific pattern that they use, right? And you can see that up here. Let me work on this laser pointer. They have their domain right here, followed by an encoded string. And if only the Apex domain is accessed, then they get this handy little error page, and that's to help hide. So if you're not the intended target, you're not finding the infrastructure before, so that you can report on it. For them, content-based hashing is extremely effective. Right now, it says 40,000 up there. We've got about 45,000 results roughly in that query. It doesn't matter how fast they spin this up. It doesn't matter how much money they're investing into it. If you have the right hash and the right set of data to search into, then you can catch everything that they're using, often with a single query. And that's what we've done here. All of the infrastructure up there, it was, as you can see on the dates, was live at the time I ran the scan. And it proves almost startlingly effective. This is our first fuzzy hash. So this is for Crypto Chameleon. This is a phishing kit that was first reported in February 2024. They harvest usernames, passwords, password reset URLs, photo IDs. What they're trying to get at is your hard-earned crypto money. They see you at home with your 17 desktop Bitcoin home server farm, and they're like, that guy, he's got money. I want it. So they're targeting all these different services, but their end goal, like most cybercrime, is to just steal your money. Now, one of the things that they do is they have their custom-built content, right? And that's great for evasion from a lot of different security products or a lot of different ways that threat hunting has been done in the past. But with fuzzy hashing, it becomes relatively simple to discover because they're not changing enough. They still need, again, like I mentioned earlier, they still need it to be close enough that it's going to fool somebody. It needs to be similar enough to that page. And if it's similar enough to that page, we can find it. Right here, we've got just over 1,300 different results. And again, it doesn't matter where it's hidden, where it's hosted. This is across the entire internet. That's the data set that we provide. The similarity search will catch it. And crucially, if you're scanning frequently enough, which we are, you will catch this infrastructure the moment it goes live, or the moment that it's registered, or the moment that they've parked it. Whatever it is, we will find it, and we will show you how to block it, or provide you the data to block it. Hash number 3, bazaar call, or bazaar call. I enjoyed doing that. You're going to have to just humor me on that one. I apologize. So these guys, essentially, they send phone numbers out, and their whole goal is to get you to call it, right? Their goal is to essentially scam you into downloading their malicious software somehow. So probably not targeting anybody in this audience, but you might have a grandmother or grandfather who might be susceptible to it. I know my grandfather is very susceptible to phone calls telling him what to do with his computer because he doesn't really know what to do with it anymore. So anyway, by analyzing specific segments of code that they used and then using the proprietary hash that I referenced earlier, we were able to track just under 6,500 different results for this threat actor. Thousands of other host names, one query, right? So it doesn't matter the automation that they're using is, again, the point that I'm going to keep hammering here. Yes, threat actors are evolving and scaling up their operations, but that doesn't mean that we have to. It doesn't mean that we have to spend hundreds or thousands of hours hunting down each individual domain as long as we fingerprint properly, and hashes are one very key ingredient for that fingerprinting process. Medusa stealer. Give me a quick second to wet the old whistle. So like the slides say, this emerged on a Russian-speaking dark web forum, Telegram channel in roughly June of last year. Infects Windows systems, steals sensitive information, all of your standard cybercrime behavior. And this one is a service, so it's popular among cybercriminals for the high level of customization and the robustness because it works. But if you've been paying attention, then that customization keyword there probably flagged your attention. Now, their panels, by the very nature of how they're constructed, have several similarities, and we can use these similarities to identify them. Doesn't matter who they sold to or what the person that they sold to is using to generate their malicious campaign of whatever it is. If they're using a Medusa stealer panel, we can track them. And in this case, we used a proprietary hash with a known ASN that the Medusa stealer panels were commonly on, and voila, 240 plus results. And the best part about this is it's repeatable. This was just on a specific ASN. You can throw it against any other ASN and see if the Medusa stealer panels are being used on that. So it doesn't matter if they hop, we can still catch them. And if you're watching for ASN changes through our platform, you'll know the moment they hop. Hash number 5, this one, I couldn't find a way to get graveyard and hash in the same image. Unfortunately, there was nothing that looked appetizing in that. So CryptBot info stealer, first spotted in 2019, capable of affecting Windows systems, very similar to the last one. Pops in and out of use, tends to change their attack and distribution methods, which makes it a little bit harder to track them. Malware creators are constantly iterating on their work, right? They're trying to get better at evasion, they're trying to make them more money, which means they have to iterate. We can just track that iteration. Now, for this specific one, sometimes the hashes aren't enough. You need the technical details, right? You got to bake that. You got to stir it. And I read that backwards, so I apologize. But for this one, we used roughly 4 or I think maybe 5 technical values combined with a proprietary hash, and the results are right there. You can see them right here. 1,283 different results for live or historical infrastructure that is using CryptBot. And it took us hours to track them. Number 2, fuzzy hash number 2. This was a sophisticated phishing cluster. We don't have exact attribution at the moment, but that doesn't matter. if you can fingerprint the way that they're spinning up their infrastructure, you can still find infrastructure that's related. You can still see what else the attacker is spinning up, and then if somebody else reveals who it's by, or if you find some more key details that you can use for fingerprinting or attribution, then you know who it is. So for this one, the web pages have some of them hidden behind captchas. Some display the phishing page right away. Others have an animation. And another thing that we've seen attackers start to do more frequently is they will pay greater attention to who's going to their page, right? And that's what we see here. They're splitting the desktops. They're serving something specific to them. They're splitting mobile users to something else. Not for this specific one, but we've also seen, and I'm sure some of you have also seen for Windows or Mac devices or specific versions, just going after that user agent string. But again, over 500 different instances of this attacker's infrastructure on a single query. So this was a content-based query, I believe, for similarity searching. Everything in this phishing cluster was built similarly, and that means that we can find it. And one of my favorite things to say about this is with the right fingerprint and the right data, it doesn't matter how they hide. It doesn't matter how widespread their network is. It doesn't matter how many zeros they got on the end of their number of domains. Everything they create can be tracked. All that matters is that there's a unique fingerprint that we can use. And by virtue of customization, by the definition of it, it's unique. And we can use it. So the dreaded double hash. This is for Fin7. We've done a lot of research on them. We currently track an extensive number of their infrastructure, but for this specific talk, we're going to cover their browser update extension. Now, Fin7's, as you can see on the slide, financially motivated threat group, links to Russia, been operating for just over a decade now. They've been collecting different aliases like baseball trading cards. And one of the key features that they use in the creation of their infrastructure are fake browser update extensions. You can see one of them up here right now. They trick users into tapping that ever popular install button, and once you do, you start moving down the malware and now I'm infected process. We noticed a change in their network infrastructure that was hosting this, which prompted us to do a little bit of digging. And through that, the way that they were using their infrastructure was a little bit more complicated for this specific part of it, and a single hash just wasn't good enough. It was either returning some false positives or it wasn't catching everything, so we combined them. We used a content hash with a network hash and sprinkled in a little bit more technical details, and then we were able to create a unique fingerprint that captured live infrastructure. And I know you guys have been seeing me dish out really large numbers, so you're like, Casey, why is that 10 there? Where's the other zeros? Well, sometimes for specific threats and specific parts of your investigation, even 10 results is a success, because those 10 results will lead you to the rest of their infrastructure. And for us, they did, because we're tracking thousands of pieces of their infrastructure right now. So, questions? Hash away. Enjoy the memes, and if you have one, please raise your hand. Wonderful. Well, thank you, everybody. I'll be around afterwards.